Welcome back to our class for midterm for week or module number 4. Our topic is about voltage division in two series resistors. So in voltage division is the result of distributing the input voltage among the components of the divider. So an example for a voltage divider is two resistors connected in series with the input voltage applied across the resistor pair and the output voltage emerging from the connection between them. So makita nato sa atuang figure for voltage division. So ang giingon ganina nga there are two resistors connected in series. So we have here our two resistor, the R1 and R2. So giingon naay input voltage which is the ET or the total voltage across. So in every resistor na siya input voltage. That's why we have E1 and E2. So there are formula on how to solve for the voltage across the R1 and voltage across the resistor 2. So we have here for E1, so using voltage division, we have E1 is equal to the total voltage multiply sa tuang R1. So first, since E1, so ang atong numerator which is R1 dapat una. So R1 divided by R1 plus R2. So for the E2 or the second voltage for the resistor 2, we have same total voltage multiply. Since E2 ang unknown, so dapat ang ato ang resistor ang numerator. R2 divided by R1 plus R2. So take note for our formula for the voltage division. So for the next topic, we have maximum power drawn by load. So the maximum power transfer theorem is another useful circuit analysis method to ensure that the maximum amount of power will be dissipated in the load resistance when the value of load resistance is exactly equal to the resistance of the power source. The relationship between the load impedance and the internal impedance of the energy source will give the power in the load. So therefore, sa ato ang power di ay naa siya'y maximum niya nga magamit. So maximum power, so ang maximum power is transferred to the load when the load resistance RL is equal to the series resistance R of the circuit. So ang maximum power transfer di ay is pwede siya, maximum power is pwede siya ma-transferred ang load sa resistance RL if na siya'y condition if equal ang series resistance sa tuang circuit. So example, makita na to sa tuang figure. We have our total voltage and the internal, so small letter R is internal resistance and naay naka-series nga RL or the load resistance. So ma-equal, so in maximum power di ay ang RL, ang load resistance is equal siya sa atuang na series nga internal resistance. So take note na for formula for the PL or the maximum, so PL is the maximum power drawn by resistance RL. So naatay formula for maximum power is equal to ET or the total voltage squared divided by 4RL. So take note nga sa maximum power ang atuang load resistance is equal to our series resistance or the small letter R. So So if we apply it sa itong example, so apply na to for our example number 1, a battery has 12 volts output on open circuit, which drops to 11.5 volts with a load current of 1.5 amperes. Find the maximum power that can be delivered by this battery. So therefore, ang unknown nato is the maximum power. First, we need to write our given from our problem. So nag-ingon siya, naghatag siya total voltage which is 12 volts output here. And naa siya RL, naa siya volts nga 11.5. So kanang 11.5 drops, so na siya nag-agi siya sa atuang resistor, so RL. So 11.5 ang atuang, so ibutang nato dire EL 11.5 volts, and naghatag siya og current. Ang current nagadagan sa tuang R, so we have 1.5 amperes. So ang unknown na to is the maximum power sa tuang circuit. So makita first, na-draw na nato atong figure. Since naghatag siya total voltage, so we need to find our voltage across atuang small letter r or the ER. So naghatag na natay total 12 minus 11.5, we have, for the voltage sa tuang small letter r, we have 0.5 volts. So solving for our R, so since wala given, and naatay current, since series man, so same current ang nagflow, so we have 0.5 divided by atong current. So ang atuang resistance will be 0.33 ohms. So pwede na nato ma-solve ang atuang maximum power since ang RL is also equal sa atuang small letter r or the internal resistance. So solving for maximum power, for our formula, we have total voltage squared divided by formula 4 multiplies ato ang RL, which is 0.33. Ang atuang maximum power will be 108.01 or approximately 108 watts. This is our final answer. So for our next topic, di ba ganina naghisgot ta og voltage division, naapud tay current division in two parallel resistors. So when two resistors are connected in a parallel circuit, the current in any branches will be a fraction of the total current or IT. If both the resistors are of equal value, then the current will divide equally through both the branches. So in parallel circuit, so pwede ta makasolve og current by using the current division. So we have here our figure. So in a parallel, na siya R1 and R2, and na ay current for our current drawn for our resistor 1, and I2, which is current drawn by resistor 2. So we have our own formula. So kanin na derived na ni siya. So you need to memorize na lang para mas dali ra magamit if na ay unknown or magamit sa parallel resistor. So, I1 is equal to I total multiply sa R2 over R1 plus R2. So, makita na to ang difference sa voltage. So, in current, if I1 ang unknown, ang atuang gamiton nga numerator is R2. So, same sa I2, if unknown ang atong second current or the resistor, sa atong resistor, we have atong gamiton is ang R1. So, for our series, so nakahisgot naman ta sa series o parallel sa atuang last module. So, naapod di ay series parallel circuits. So, kaning series parallel, combination ni siya. So, two terminal components and electrical networks can be connected in series or parallel. So, nga to ang electrical network di ay pwede siya ma-connected by series or parallel o pwede ang duha. The resulting electrical network will have two terminals and itself can participate in a series or parallel topology. So, components connected in a series are connected along a single electrical path. So, kabalo na taan na. And each component has the same current through it, equal to the current through the network. The voltage across the network is equal to the sum of the voltages. So, ang components also in parallel, so nahisgot na ta na last topic, so are connected along multiple paths and each component has the same voltage equal to the voltage across the network. The current through the network is equal to the sum of the currents through each component. The two preceding statements are equal except for exchanging the role of voltage and current. So, ang ilahang mga equivalent, so dili siya pwede magkabaylo. So, in case sa atuang voltage and current. A circuit composed solely of components connected in series is known as series circuit. Likewise, one connected completely in parallel, so it is known also as parallel circuit. Many circuits can be analyzed as a combination of series and parallel, along with other configurations. So, we have our formula. So, makita nato dire in a series parallel, so we have our total voltage and nakaseries siya for our R1, and after sa atuang R2, ang R2 and R3 is parallel ang atuang circuit. So, kanina figure, therefore, we derive na for solving sa atuang total resistance, so therefore, ang formula will be R1 plus, so series, kanidere, series, plus ang R2 ug R3 which is, ang R2 ang R3 na to is parallel. So, we have 1, formula sa atuang total for parallel is 1 over R2 plus 1 over R3. So, take note that for food for the brain, the circuit is a combination of series and parallel connections. But when simplified, so kung i-simplified din nato, ang final circuit is a series circuit. So, if we apply for our example sa series parallel, a 10 ohm resistance is connected in series with two resistances in parallel of 7.5 ohms and R. What the ohmic value of R if the total current drawn from a 20 volts DC source is 1.5 ampere. So, first, we need to write our given. So, naghatag siya E total which is 20 volt and naghatag siya og current which is 1.5 ampere. So for our R1, we have 10 ohms and our R2 is 7.5 ohm and therefore our unknown is R3. So sa atong figure, since masabdan na to sa atong problem, so naay gadagan nga 1.5 current sa atuang R1. And our R2 and R3 is parallel. And natay 20 volts nga total voltage or our source. So pwede na to ma-solve daan ang atuang total current since given ang total voltage and the total current. So solving for total resistance, we have 20 volts divided by 1.5. So our total resistance will be 40 over 3 ohms or 13.33 ohms. So makita na to sa tong circuit. So we have for formula for the total resistances. So ito ang atong gisolve ganina. So ang R1 series plus sa parallel sa R2 og R3. So R1 plus 1 over R2 plus 1 over R3. Since naatay total current, total resistance rather, na-solve na nato ganina, so substitute 40 over 3 is equal to 10. So ang 10 is atong R1 plus 1 over 7.5 plus 1 over R3. So solving for our R3 will be 6 ohms. So isolve nato using shift solve technique. We have 40 divided by 3. So we have 10 plus 1 over 1 7.5 parallel sa atong R3 which is ang atong unknown 1 over alpha x. So solving for R3, if x is 0, so our R3 will be 6 ohms. So pwede ta makagamit aning shift solve technique if complicated ng atuang equation or pwede if nagdali na taog solve. So pwede po na siya ma-solve if i-simplify pa pero taas na kayo ato ang process. So for our last topic, for our module number 4 for midterm, so ganina naghisgot ta og series parallel. Now we have also a parallel to series circuit. So food for the brain, the circuit combination of series and parallel connections, but when simplified, the final circuit is parallel circuit. So what if if una ang atuang parallel, so connected siya, so mahimo siya og parallel circuit. So example, in ani na figure ang given, we have our total voltage and our R1 which is nakaparallel and nakaseries ang atuang R2 and R3. First, we need to kaning duha solve nato ang atuang series. So ang giingon ganina nga ang combination, so therefore ang simplified final circuit will be parallel circuit. So solving for our R total, we have 1 over R1 plus 1 over R2 plus kaning duha R3 since naka-series man siya. So apply na to sa tong example. So a 12 ohm resistor is connected in parallel with a series combination of the resistor 8 and 16 ohm. If the voltage drop across the 8 ohm resistor is 48 volts, what is the value of the total current? So therefore, first we need to write our given. So given na to. So to ang problem. So we have our given. So naghatag siya 12 resistor. So we have our R1 12 and our R2 and R3, so 8 ohms and 16 ohms. But giingon dire ang voltage drop across sa 8 ohms is 48 volts. So we have our E2, so na siya 48 volts. So ang unknown nato, so ang total voltage is same since nakakonect siya in parallel. So therefore, our total voltage is 48 volts. So solving, so first, need ang given man nato is kaning sa atoang R2. So naman siya current and resistor. So pwede nato ma-solve ang current. So solving for current I2, so ang formula diba is E over R. So we have 48 volts divided by 8 ohms. So ang current nga gadagan sa atuang resistor 2 or the 8 ohms is 6 ampere. So solving for our E total, so we have here 6 times 6 plus 18. 16 plus 8 rather. So asa man tagikan aning 8. So dire sa atoan 16 sa 8 na atay given. So i-solve nato from here. So we have 6. Ang gadagan dire which is 6 ampere, we have 16. So 16 ohm plus 8 kaning 8 ohms. Therefore, ang total current here is 144 volts. So we have 6 times. So pakita nato sa tong calcu. 16 plus 8. So 144 volts. So kaning 48 volts, dare ra ni siya sa tuang kadagan. While ang atuang dire for the series nga 8 ohms og 16 ohms naa siya gadagan which is, so ang total will be 144 volts. So therefore, ang atuang total current ang bag-o nato which is, so wait, erase na to. So 144 volts na siya. So since naa na tay total voltage, so solving for I1 or the current 1 nga gadagan dire sa 12 ohms nga resistor. So we have 144 divided by 12. So total for the current of I1 we have 12 amperes. So solving for our total current, so from I1 to I2 sa ato ang series. So sa atong parallel, una which is 12 amperes. So we have 12 plus ang nasolve nato ganina na current for I2. So ang current, so same raman since naka-series man siya. So therefore 6 amperes. So our total current will be 18 amperes. So I hope nasabtan for our example for parallel series circuit. So ganina, so ibalik ko na ko ha katong 48 dire. So diri ra to siya sa voltage drop for our E2. While ang atong total voltage since naka-series then naka-parallel siya dire. So therefore need na to i-solve una ang voltage drop sa duha and plus voltage drop sa atuang parallel dire. So therefore 144 ang atuang total voltage diay. So I hope nasabtan. So please study in advance for your midterm exam. So if you have any question, pwede maka-comment sa tuang Google Classroom para matabangan ni ma'am. So that's all and thank you.